In this tutorial, I want to show you a couple of ways in EViews to help you uncover whether or not your series has a seasonal component. I'm going to do this with the series SP500. So I'll begin by typing the EViews command show SP500. Now conventionally, the stock market isn't viewed as having a seasonal component. It doesn't have variations that are regular, systematic, and occur within a year. One way we can begin to look at this is a simple graph of a seasonal means. This is a nice feature of EViews, and what this provides you with is a graph of the mean values for the January, February, March, April, May through December. It's the red lines here, and then all of the January values collected together. The fact that the January, February, March, each of them seem to increase dramatically over time is simply indicative of a strong trend in this series. There's no obvious difference among these, no obvious seasonal peak or seasonal trough. So on a visual inspection, it doesn't appear that there's a statistically significant seasonal component. Now in this work file, I've got seasonal dummy variables, variables that equal 1 in, say, the first month for the January variable, January 93. You scroll down, you're going to see every January is 1, all the others are 0. We call that a dummy variable. It's either 1 or 0. Here's the command I used, jan equals @seas equals 1. I used the seasonal function. Now I could run a regression. In EViews, the command ls runs a least squares regression of SP500 on all 12 of these dummy variables, Jan, Feb, March, April, May, June, July, August, September, October, November, December. Notice that I haven't included an intercept term. You're going to check your understanding of econometrics here, but when I run this regression, I don't have to worry about perfect multiclinearity. And in fact, what I get are the mean values for each of the 12 months of the year. The seasonal mean for the S&P 500 in January is 11769. Now, if I want to test for statistical significance of the difference, I'd want to add an intercept term. So I'm going to estimate this again, add an intercept term, a C, and drop one of the 12, because remember, I can't have all 12 of these and the intercept term, otherwise I'll have perfect multiclinearity. The reason I'm doing this is that running it this way, each of these are relative to the omitted, or interpreted relative to the omitted month, in this case December. So on average, January is lower than the average December value by 26.9 units, although the difference is not statistically significant. And we notice that none of these are statistically significantly different from December, another indicator that we might not have a statistically significant seasonal component. However, the correct way to do this would be an F-test. In other words, are these parameters jointly equal to 0? Well, fortunately, the default output from EViews and most statistical packages, it gives you an F statistic for overall fit. In other words, it tests the null hypothesis that the coefficient for January, February, March, April, May are jointly equal to 0. And we get an F value of 0.03 and a P value of 1.00, meaning that we cannot reject this null hypothesis at any statistically significant level of significance. 1.0 is, 100%. And so therefore we can conclude that there is no statistically significant seasonal component to the S&P 500.